Now that we know what to look out for in terms of mass, charge, baryon number, lepton number and strangeness, it's time for us to start looking at the particles themselves, and we're going to do that by getting a little bit of structure and seeing how the world of the particles all fits together. So let's look at the family tree, some taxonomy if you like. We're going to put the particles into groups, and this can be done in a number of ways, but this is a nice simple way. Now, I suggest you sketch this out and fill it in yourself. It's just not the same when you copy and paste the completed thing. You can always pause, remember. Alright, so first off, leptons and hadrons. So things are either leptons, which means they have a lepton number of 1. Particles in this group include electrons and neutrinos. Or they can be hadrons with a lepton number of 0. Anything with a quark is in this group, so that includes protons and neutrons. We can then split the hadrons into two groups. Hadrons with a baryon number of 1. These have got 3 quarks in them, such as protons and neutrons. And mesons with a baryon number of 0. And these only have 2 quarks, such as pions, which you've probably never heard of before. So far, so easy. But sorry, I can't leave it there, because I try to avoid mentioning antimatter, but it just makes this chart wrong. Every particle actually has an antiparticle version as well, with the opposite charge and some other odd things which we won't go into. The electron has a charge of -1e, and its antiparticle has a charge of +1e. It's called a positron, because it's positive. Also, the antiparticle has a lepton number of -1, so I should change this to say that leptons have a lepton number of +1 or -1. It's also relevant over here because baryons are made of 3 quarks or 3 antiquarks, and that actually means they can have a baryon number of +1 or -1. Mesons are made of a quark and an antiquark. So that's the family tree. We need to go back to the safe, familiar proton and neutron now to learn more about quarks. Neutrons and protons are both baryons, which means they have 3 quarks. Let's focus on the neutron first. The neutron has 2 down quarks and 1 up quark. The proton has 2 up quarks and 1 down quark. Now yes, physicists must have been going through a silly phase, and so quarks have silly names. When they call it an up quark or a down quark, that doesn't mean it's pointing up or it's moving down or anything like that. It's just a name, it's words, it's letters. Okay, so it's just an up quark and a down quark. There's actually 6 flavors of quark, which are up, down, strange, charm, top, bottom. Yes, I said flavors, and they've all got silly names. Let's focus on up and down, because those are the 2 in our everyday lives. In fact, now come to think about it, the whole world around you is made from just 3 particles. Up quarks, down quarks, and electrons. Everything is made out of only those 3. We only get the other things in particle accelerators and the sun and the like. Right, so looking again at these quarks, as you can see, these quarks have charge, but not a full E's worth. The up quark has a charge of plus 2/3 e, the down minus 1/3 e. So that means a neutron has plus 2/3 minus 1/3 minus 1/3, giving a total of 0 charge. The proton has plus 2/3 plus 2/3 minus 1/3, giving a total of plus 1 e. Up quarks and down quarks are very normal, as I said, and they're all around us. And in fact, we're made of them, remember? And so they have a strangeness of 0. They also have a lepton number of 0 because they are not leptons. And they have a baryon number of 1/3 because we need 3 of them to make a baryon. And that's most of what you need to know about quarks, although we do need to look at nuclear reactions still. To finish off though, let's look at something strange. Now, after the discovery of the neutron in 1932, people carried on looking at lots of other things and trying to discover other particles, and some of the particles that they did discover, well, they seemed odd in some way, unusual, strange. And so that's where the idea about strangeness came, because in order to classify them, and still in their silly period to be honest, the physicists decided to give these particles a property that they called strangeness. Now, later on, they started to find out that actually their neutron and things like that are made up of smaller particles. They're made up of particular quarks. And what they found out was that all these particles that had some kind of strangeness attributed to them, they actually all had the same kind of quark in them, the same flavor of quark. And so they called it the strange quark. Now the omega baryon has 3 strange quarks in it. And that means it's got a strangeness of -3. Yep, that's right. Strange particles have a strangeness of -1. And they also have a charge of -1/3. So that means an anti-strange is going to have a strangeness of +1 and a charge of +1/3. You're more likely to come across the kaon, though. It is a meson made up of strange and up or down quarks or antiquarks. K- is a strange quark with an up antiquark. So that means it has a strangeness of -1 and a charge of -1/3 e plus -2/3 e. Now, remember, it's an anti-up, so its mass is the same as an up's, but the charge is positive. And that means that overall the charge is -1 e. The baryon number is 0 because the strange quark has a baryon number of +1/3 and the anti-up has a baryon number of -1/3. And that's about as much detail as we want to get into concerning the family tree of particles. I'm sure you can tell that there's a lot more detail to it, but nothing that we actually need to know at the moment. It's a lot to take in, but hopefully you're finding it fascinating. What we need to do next is get back to something useful. We're going to look at beta radiation. We know that in beta radiation a neutron is going to change into a proton, but now we know what's inside the neutron and what's inside the proton, which means we can get closer to the truth about what's actually happening with these particles and understanding exactly what fundamental particles really are.